Hi, today we're going to take a look at the quadratic formula. Now, this is just another way that we can solve quadratic equations, just like we can solve by graphing, we can solve using square roots, we can solve by factoring, we can also solve quadratic equations using this formula. Now, this is a pretty complicated formula in terms of how it looks, but it's really not that bad when we break it down into steps. So I'll explain here in just a minute. So first of all, with the quadratic formula, it's important to make sure that the equation that you're working with is written in standard form, just like we see here in the middle of the screen. We need to have the equation in standard form so that we can identify the value of a, which will be the coefficient of x squared. The value of b is the coefficient of the x term. And then the value of c, which is the constant term, okay, the one that does not have an x attached to it. But again, it is extremely important that you have your equation in standard form like this. So it just says equals 0 on the other side, and everything else is written in order before you identify A, B, and C. Otherwise, you're going to get the wrong answers. Now, in this formula, all we're doing is we're substituting in our values for A, B, and C. So you'll see that the value of A is only used 2 times, or twice. The value of b, that coefficient of x, is substituted and used twice. And the value of c, our constant term, is only used 1 time. So each of those numbers is used in this calculation. And when you substitute your values for the variable and evaluate this equation, we'll actually get both answers of every quadratic equation, both solutions. All right, so here's the steps that we want to follow when you're using the quadratic formula. So first and foremost, just like we talked about, identify A, B, and C from the standard form of the equation. Then we substitute A, B, and C into that quadratic formula, so just this quadratic formula here. And then we evaluate the radical. So this b squared minus 4 times A times C. We want to figure out exactly what number that equals. Okay, so it looks complicated, but if you just break it into parts and try to figure out what are we actually taking the square root of, do that in our third step. Then finally, you have the square root of a number. So simplify that square root if possible. Hopefully, you end up with a perfect square there, something you can actually take the square root of. And other times, you'll just have a square root that you can simplify. Step 5 says to simplify the numerators if possible. So that's, we have this plus minus symbol here. We've seen that a little bit in our other work. So that just means I want to take this first number and add it to the square root of whatever. And then I want to take this first number and subtract it to that, whatever that square root number is. Okay, so that's simplifying your numerators if possible. And then divide by whatever's in the denominator. Okay, that's kind of your last step. Now, if you can't divide it out evenly, we just reduce it like a fraction. And when you're done, please make sure that you always have your 2 solutions. So let's just do some practice with identifying A, B, and C. Okay, just getting those values before we get into this complicated formula. So a reminder that A is the coefficient of the x squared term. Okay, it's whatever number is in front of x squared. B is the number in front of the x term. C is the number that doesn't have a variable. It's that constant term. So in example number 1, I don't even see a number there in front of the v squared, in front of the quadratic term. When I don't see a number there, I know then that that number is actually 1. It's like that invisible 1 in front of the v squared. Now in front of the v to the first power, we have a positive 2. So b is positive 2. And then last, in the constant term all by itself, it says minus 8 at the end. So that tells me that c is actually a negative 8, not just a positive 8. It's actually negative 8 because of that subtraction there. So a is 1, b is 2, c is negative 8. Take a look at number 2. See if you can identify a, b, and c in that quadratic equation. All right, so hopefully you got the same thing here, that a is 1 because of the 1k squared, that invisible 1. B is 5 because it was 5k in the middle. And then because our equation ended with -6, c is -6. Let's take a look at our last couple of examples here on just identifying a, b, and c. All right, in this example, we notice it's still in standard form. It says equals 0 at the end. So a is 2, b is -5, and c is +3. Pretty easy, right? Well, let's take a look at example number 4 and see how we do. The problem with example 4 is our equation's not in standard form. Did you notice that it doesn't say equals 0 at the end? It says equals something else. The first thing we want to do is subtract the 2 from each side. Now, what do I subtract it from on this quadratic side? Well, it's a constant term, so I subtract it from the other constant term. And when I do that, I'm still going to have 2a squared minus 1a, but now I have minus 15 equals 0. So now when I look for my values of a, b, and c, I can see that a is going to be 2, b is going to be -1, and c is going to be -15. A is 2, b is -1, there's that invisible 1, and c is -15. So it's important to make sure that your quadratic equation is written in standard form before going any further.